Hello YouTube, in this video I will attempt to make a chuck backplate for the emcoturn lathe, and I got a piece of 4140 roundstock mounted here, and I thought that I will start off with some drilling. Now mounted a 6mm end mill from Sandvik, a 3-fluter. It's 68.99mm, and it's supposed to be 70, but I chose 0.5mm stock to leave. That will be on each side. Alright, so I'm now trying to check here with the caliper. It's 70mm we are going for, but it's kind of hard to measure with this one, but I think it's pretty much spot on. So now it will need to be some counter boring, and I now mounted an old sandvik drill. I don't know how old this drill might be. If you recognize this type of box, from which time period it was produced, feel free to comment about that. Right, so as you can see, I now started up the old emcoturn, and the plan is to build a turret, but it will take me some time, so I'm thinking that I will start off with just mounting one of those Sandvik capto clamp units that I have. I got 3 of them now, and the tooling looks like this. It is, I think it's called polygon shaped, and it is kind of like a thing in here that expands. Sorry about the wind. That expands and then pull this one in here into the polygon shaped what is it called, socket perhaps, inside there, or sleeve, I don't know. Anyways, I plan to mount some of these on the turret that I will build, but for now I'm thinking that I will only attempt to mount one sideways so that I can turn the backplate and mount the chuck and perhaps try some basic turning out. And this one here is actually for Murasaki lathe. I think that is very nice lathes. But this one will need to be modified a bit. So I will start off with trying to drill a hole straight through here, or actually I will try to drill 50% and then I will flip it around and drill the remaining 50%. And I suspect that this one here might be pretty hard, so I actually got one drill here from YG or YG1 that this one is for hardened steels. So this is how it looks, and it's important to not get chips inside here. And here we got the hole, and got a M8 bolt. This one is now stuck with a screw here, but it needs to get stuck a bit better. And this one is now mounted so that I can turn the back plate, but once the back plate is turned and the chuck is mounted, it will be much better to have this one mounted a bit more in this direction. So I thought that I will just make something simple. So I now mounted a piece of aluminium here on the minimill. Take a look at that finish. So I'm now thinking that I would like to test my latest by 25mm solid carbide end mill. I've been looking for one since this winter for a good price, second hand. This one I bought for, I think it was 24 euros, new grinded. Looks very good. And I don't need this one for side milling or face milling. This one I will use only for making flat bottom holes. Right, so I now mounted this piece of aluminum here, and as I said, this is just temporary for turning the chuck backplate. This don't look good at all. But the plan is now to remove this one and then take a long drill and drill a little bit to make some spots where the holes needs to be. Then drill the holes and tap them. Right, so now drilled and tap the holes. However, I didn't record it. So the only thing left to do now really is to remove this little thing here with these two that I couldn't mill off due to travel. So I'm thinking that I will stand this one up now and chamfer it just a little bit. Right, so this is how it turned out. This one is now pretty stuck, so hopefully it will do to turn the back plate with. Nice finish. But now it's time to go to bed, so I will have to wait until tomorrow to do the test turning. Really looking forward to that. Been wanting to try this one for a very long time now. First time trying a real lathe out, and got the spindle set to about 300 RPMs. Let's try and jog into this one and see what will happen. Didn't really cut in much at all. Let's give it a new try. Oops. Right, so at 300 RPM, the 1 kV servo seemed to be able to take off 0.05 millimeters. So I will now try and raise the speed up to 500 RPM and try 0.1 millimeters. Let's try 0.15 millimeters, which I think the inserts are made for. I will upload this on Instagram. I'm super happy for just this little bit of turning. Now it seems to work pretty okay. I think I could raise the speed up a bit. tight still. Oops, did I just hit the insert with the chuck? That was not good at all. Alright YouTube, I'll have to end this video here since the memory is completely full with videos on my phone, so can't do any more recordings. Need to edit the footage and upload it on YouTube. I'm not completely done with the chuck backplate, but I will still call this a success since I had no experience at all when I started to machine this one on how to use a lathe or the programming or like that. So although it ain't too complicated, it is very easy to do a mistake and can be a bit, although this is stuff that I bought cheap, can still be very expensive for me. So yeah, huge thanks for watching, and to all the people that have subscribed. I get a small payment from YouTube from ads now, and it seemed to be between $2.50 to $3 a day. So I hope to get up to about $100 a month. It will help me out a bit with this hobby. So please press thumbs up and subscribe, and if you haven't done that already, and comment as well. I happily receive some tips or feedback or input, since I don't know a thing about this really. But yeah, I know a little bit more now than when I started off though. So yeah, it will be a process learning, turning. It's not that hard, but it's easy to make a mistake. That is the way I feel about it currently, and I'm actually very pleased that I don't have a turret to think about. That will be a bit over my level or my skills at the moment. So this will have to do for some time, and then I will build a turret this winter or next year with some live tooling. Alright, see ya.